All right, guys, today we're going to be going over the review sheet for your pre-algebra midterm test. All right, first one says, write an equation for the line shown. Identify the slope and the y-intercept. Well, we know the equation for a line is y equals mx plus b. So, m is the slope, which means the rise over run. If I find 2 points where I see it going through, I see here and here, and so I see it goes up 1, 2, 3, and goes over 2. That's a rise of 3 and a run of 2. My slope is positive since it's going upward from left to right. So I know this is y equals 3 over 2x. And now I have to see where it crosses my y-intercept to know what b is. Well, this is 0 up here. So that would mean this is 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be a negative 8. All right, let's try number 2. Number 2, once again, we're going to use the same linear equation, but this time we notice that it's going downward. So I know this is going to be a negative slope. Let's see what the slope change is. We see that there's a dot here. It also crosses here. So that's 1, 2 down and 1, 2, 3 over. That's going to be 2 over 3. And now I have to see where it crosses my y. Since my 0 axis is here, 1, 2, 3, up from there would be a positive 3. All right, it's time to go to number 3. All right, number 3 says 3x plus 9 equals 6x minus 3 plus x. First, I have to combine like terms on each side. I see I have 6x plus x. That's going to make 7x. Let's rewrite that problem. That gives us 3x plus 9 equals 7x minus 3. Remember, 6 plus 6x plus x is like 6 x-ray machines plus 1 x-ray machine. Now that we've combined all our like terms on each side, we have to do Pemdas backwards. So first thing I'm going to do is move this x over here because this will give me a positive x. If I move the 7 over, it would be a negative 7, which would create a negative x. Then I have to divide a negative 1 from it anyways. So right here, let's go ahead and minus 3x, because whatever we do to one side, we do to the other. That's going to bring us 9 equals 4x minus 3. Now I got to get rid of that 3. I'll add 3 to this side, which means I have to add it to this side. I'm moving the 3 instead of the 9 because I want to get x by itself and isolate it. That means I got to move all the numbers away from it. Well, 9 plus 3 is going to give me 12. So now I have 12 equals 4x. I need to divide 4 away from 4x so I can get x all by itself. Whatever I divide from one side, I have to divide from the other. 12 divided by 4 is 3. That tells me that x must be 3. All right, let's go to the next one. For number 4, I see I have to distribute properties. I'm going to take the 3 and multiply it to everything inside of my parentheses. 3 times x is 3x. Well, let's write this out of the way. And 3 times 9 is 27. And that has to equal 6x minus 3. Once again, I'm going to move my smaller amount of x's to the other side. This will give me a positive x over here, so I don't have to worry about dealing with a negative one later. 6x minus 3x is 3x. So now I've rewritten my equation to read that 27 has to be equal to 3x minus 3. Well, I need to get rid of this negative 3, so I'm going to add 3 to it. Whatever I add to one side, I have to add to the other. That's going to leave me with 30 equals 3x. Now I have to divide 3 away from x, so I can get x by itself. Now that I've isolated my variable, I realize that whatever I divided from one side, I have to divide from the other, and 30 divided by 3 is 10. That means x must be 10. All right, we're moving on to number 5, which seems kind of easy next to the others. First of all, I'm going to go ahead and move this positive 5 away from here. I'll subtract 5 from it to get rid of it. Whatever I subtract from one side, I subtract from the other. 45 minus 5, that's going to give me 35. So let's rewrite this over here. Now I've got 35 equals 5x. Well, this seems pretty easy now. I need to isolate x, so I'm going to divide 5 from it. Whatever I divide from one side, I divide from the other. 35 divided by 5 is 7. So that means x must be 7. All right, now that I see that I've got number 6 to do, let's see, we've got 1/5 x plus 3 is equal to 7. Well, I know that I've got to go ahead and subtract 3 from both sides. And that's going to leave me 1/5 times x equals 4. Now I have to realize I have to multiply the inverse to get rid of this 1/5. The inverse of 1 over 5 is 5 over 1. Whatever I multiply to one side, I multiply the other. This will give me 4 times 5, which is 20. So x must be 20. All right, number 7 says the data on the table is linear. That means it's going to make a straight line. What is the slope of the line? Well, I know that whenever I'm making a table, that x is going to be on the top and y is going to be on the bottom. And I know that the slope of a line is always y over x. So that means this is 32 over 4. A different way I could do this is to also say that there's a difference of 4 between each one of the ones on my hours. And there's a difference of 32 between each one of my earnings. This will also give me 32 over 4. Now I have to remember that a refraction is a division problem. And 32 divided by 4, that's going to be 8. So my slope must be 8. All right, number 8 says we're going to go ahead and identify the y-intercept. The y-intercept is where the line goes through y. Over here, I see the y is crossing with my x. Let's see here. This one says 4, 5, and this one says 0, 4. So if this is y, and this is x is always first, so that means this is x, my y-intercept is crossing through 0. So if I had to intercept my, identify my y-intercept, that would be, oh, the y-intercept is b, so we would just give the answer, and that's got to be 0, or the origin. Remember, the origin is the very center of my graph, where x and y meet. All right. Yeah, this would be, wait a second here. Tricky, tricky. Remember, it's where intercepts through y. Wow, almost fooled me. Hope you followed along. This says 0 right here, which means my origin is actually down here with my y and my x. That means it's crossing through 1, 2, 3, 4. That means my y-intercept has to be 4. Whew. Glad I caught that one. All right, guys, let's go to the next one. All right, in number 9, it says tell whether each function is linear or nonlinear. Linear means it makes a line, which means it's going straight through. All right, in this one, it's saying it's going through my y-axis at y when x is 1. All right, but then there's a difference here of 1, 2, 5, and 7. All right, this can be confusing. From 1 to 2, there's only a difference of 1. But from 2 to 5, there's a difference of 3. From 5 to 7, there's a difference of 2. Now over here, from 6 to 11, there's a difference of 5. So my first two coordinates are telling me that this is going to be a slope of 5. So in other words, it's going to go up 5 and over 1. But the difference from 11 and 26 is going to be different than 5. Let's see. From 11 to 26, that's going to be a difference of 15. Well, now I have to take the 3 on the other side and divide that. 15 divided by 3 is also going to give me 5. All right, let's try this last one. From 26 to 36 is a difference of 10. But there was a difference of 2 over here. So that's 10 over 2. If I look at every one of these, I realize that all of them are a difference of 5. So that tells me this is a linear function. All right, let's go to the next one. All right, next we have number 10, which says the function ax is 2, 3, 4, and 5, and the next one is 4, 8, 16, and 32. Well, over here we see we have an increase of 1. 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5. So each one of these has an increase of 1. Over here we see we increase by 4 on this one, and we increase by 8 on this one, and we increase by 16 on this one. This, in fact, is not going to give us a linear problem. Look, our first one is 4 over 1. Our second one is 8 over 1. And our third one is 16 over 1. These are not equal to each other. So this is not nonlinear, okay? This is nonlinear. Oh, let me erase that. I don't want anyone to think I'm scratching out The answer is non-linear for number 10. All right, let's erase all this out and get to number 11. This one, it says a line passes through the point 2 and -9 and -2 and 3. Well, if I was going to go ahead and work this, I would say that I have, let's see, well, let's just say I had a table here. And in this table, remember x is the first number, so that'd be when x is 2, y is 9. When x is -2, y is 3. Well, that means 2 and then -2, right? So that's going to be a difference of 4. Now, I know you might be thinking, are you sure about that, Mr. Mills? And think about it on the number line, right? If I have 2 over here and 0's over here and -2's over here, that is a difference of 4, right? 2 this way and then 2 more this way. And then over here, 9 minus 3 would be a difference of 6. So we'd have 6. And we are going down here. So, well, yeah, we're taking the number and minus it from the other one. So that would be 4, which would give us 1 and 1, let's see, 1 and 2/4, which is 2/4 can be turned into 1/2. So that would be 1 and 1/2. So I would either have 6 over 4. We could also say that was equal to 3 over 2 because we're both divisible by 2, right? But that would also turn into 1 and 1/2. So I would say that my slope would be 1 and 1/2. For those that are wondering if that's true, Mr. Meadows, are you slipping up on us here? Let's go ahead and use our equation that we have for slope, and that is y2 minus y1 over x2 minus x1. When we do this, we see, well, let's label this one. We'll say that this is going to be my 1, and this is going to be my 2. So my y2 would be -2, and it would be minus, well, then it would be y1, and, and I'm sorry, I kind of messed that up. I did the x's, didn't I? This is the y, this is the x, so in actuality, this would be 3 minus 9. And over here would be, let's see, y or x2 be minus 2, -2, minus 2 again. And this is going to give me 3 minus 9 to give me -6 over, well, that's going to be -4. Remember, a negative divided by a negative is a positive, so this is really just going to be a positive. And 6 over 4 is the same thing we had over there. That's going to end up giving us 3 over 2 when reduced, which turned into 1 and 1/2. So no matter how you use it, we see that the slope will be 1 and 1/2. All right, let's move on to number 12. Number 12, it says, Lena makes home deliveries for groceries for a supermarket. Indicate what occurs in intervals 1, 6, and 9, showing an increase, decrease, or a constant. So let's see, indicate what occurs in the intervals 1, 6, and 9. On interval 1, it appears to me that she very quickly is leaving the area that she's at and moving away from that area in a short amount of time. Let's just say every one of these is going to indicate a minute, okay? So in a minute, she went in a very quickly, in a good amount of time. Let's just say if this was miles, or let's just say, I don't know, uh, yeah, then she traveled 2 miles in 1 minute. So that's pretty quick. Now, what happened in number 6, interval 6? Well, this is a little bit confusing. Oh, that's 5. Okay, here's 6 here. In 6, it goes straight across, which means when she got to this particular place, and she says she makes home delivery. So what looks like it happens is she's traveling very fast, and she probably stopped at a stop sign or something, and then she traveled very quick again at the same pace, and then she stopped again, might be at a stoplight or something. She traveled very quickly again at the same pace, and then she stopped at a long time. It looks like this is when she stopped at the grocery market. Okay, uh, she makes home deliveries. Well, wait a minute. That would mean that this is where she works, and she went to a home delivery. Okay, so she stopped there to drop off her stuff. So I would say number 1 is leaving work. Number 6, let's see, 1 is leaving work, leaving. And number 6 would be, I would say that would be equal to making her delivery. Okay. And then number 9 would be going back to work. All right. Returning to work. All right. Oh, that was very ugly there at the end. Work. Sorry about that. All right. That's how I would describe that. So that would be an uh, increase here, then a constant, and then a decrease. So uh, number 1 would be an increase, number 9 would be the decrease, and the constant would be across number 6. All right, so let's go to number 13. Number 13 is saying, is there a positive association, a negative association, or no association in the scatter plot? And what they simply mean is the association of dots, are they forming in a positive slope, a negative slope, or no association, which would be straight across or scattered everywhere, actually? So we see here that the dots are going downward, and that tells me that this is going to be a negative association. Remember, if I have a line that goes down, it's a negative slope. So an association of dots would be a negative association if they go down from left to right. All right, let's see about number 4. Number 14, it says you ask 50 employees if they live within 5 miles of work. Complete the two-way frequency table to show the results of the survey. Well, if I was going to use this, I'd have to go ahead and use a little common sense. I know if the total is 12 and there were 3 men, well, I would take 12 minus 3, and that's got to leave me 9, because I know 9 plus 3 equals 12. This also helps me over here because I know that if there are 12 total uh, in this area, and then there are 50 total here, remember the total is all these together. So 50 minus 12 would give me 38. So that fills out that block. And now that helps me here, because if I have 38 minus 19 women, well, that's going to leave me 19 men. And this also helps me because remember, I'm got the total here. 19 plus 9 should give me, well, 18 plus 9 is 27, so I imagine this is going to give me 28. And this should add up. 22 and 28 does make 50. So this is perfect. My table is complete. All right, let's go to number 15. I decided to get the rest of these up on here. Let's go with this one. Write 806 million in scientific notation. Oh boy. Well, remember, scientific notation demands that we put our decimal after the first number. So we know, let's see, this is going to have to be 8.06. And now we have to count how many we moved over to get that decimal there. That's 3, 6, 7, 8. So that would be times 10. And let's see, we're going to have to say to the 8th power. That tells me when I undo this, I have to move it 8 in the other direction. Now, next this says, write this in scientific notation. Wow. All right, so again, we're going to have to move that decimal over forward this time, right? So this would be 5.67. And let's see, how many do we move it over? That was 2. So times 10. And remember, we're going to have to make this a negative 2, I believe. Let's see if that's right. Remember, we're not moving it forward. We're moving it backwards this time. So we'd have to go minus 2 to get it back to where it was. Now it says here, write the expression as a power. So they're wanting us to write this expression as a power. Well, we know that when we're multiplying the same base and we have exponents there, we're allowed to add the exponents. And 5 plus 6 is 11. So this would equal 7 to the 11th power. But when we are multiplying exponent to exponent, that's different. That means we're allowed to go ahead and multiply these together. 8 times 6 is 48. So this would be 19 to the 48th power. All right, let's see if there's any others. Nope, looks like that was the last one. So I hope that helps you prepare for the test. We'll have another review sheet possibly on Monday. But for right now, I want you to try to work these out as best you can alone without the help of the video, and then see how you do. All right, when you go ahead and you've got it down to where all your answers are right, you're ready. All right, talk to you later and see you Monday.